Okay, so to get started, let me introduce today's chairperson. Dr. Hui Kim is a Gemini instrument program scientist. She manages new facility instrument projects for IGRINS 2 and also supports instrument development. Her research interests are very close to mine. She's interested in studying formation of star clusters and resolved stars in star-forming galaxies in the nearby universe. And she also has an interest in instrumentation. Hui will be chairing and introducing the remaining speakers for today. Hui, do you want to take it away?
Yes, thanks, Janice, for the nice introduction. So my name is Hui Kim, and I'll be chairing the first day of the first ever virtual Gemini science meeting. So before we begin, Janice already introduced how to use the Whova app, and I want you to go to the session that our next speaker will be in, the Jennifer Lotz session. And you can see there's a Q&A tab, so please use the Q&A tab. And we are not monitoring the Zoom reactions. So even though you raise the hands, we will not be able to see it. So don't let your hands get tired. And there's a vote button to place your favorite question to the top. So I can see that question is people's favorite, then I'll read that question first. And I'd like to introduce Jamika Marshall. She's gonna be acting as our moderator and also timekeeper. So she'll give us a warning when the speaker runs out of the time. All right, so let's welcome our first speaker of the day, Dr. Jennifer Lotz, Director of International Gemini Observatory, and she'll talk about the state of Observatory. So please start sharing your, yeah. I see your screen and I see your video, so please go ahead.
Okay. All right. Thank you very much, Hui and Janice. I'm Jennifer Lotz, the Director of Gemini Observatory. And it's my real pleasure today to kick off this very first virtual Gemini science meeting and to give you all an update on the state of Gemini Observatory. So, wow, we were blown away by the response to our virtual science meeting. When it became clear that we weren't going to be able to hold the in-person Gemini science meeting in Seoul this year, I asked Joanna Thomas Osip and Janice Lee if they could put together a virtual science meeting to bridge the gap, because it's been quite a long time since we've had a chance to interact with the Gemini community, hear about all the science you're doing, and for you to hear from us about what we've been doing here at the observatory. So we've got something like 475 registrations from people from 31 different countries, 5 different continents, and 15 time zones. So thank you all for your interest in Gemini. Thank you all to the speakers who've agreed to participate. And thank you very much to the Scientific Organizing Committee and the local organizing committee for bringing this together. And I also want to give a shout out to those people in time zones where it's very late at night or very early in the morning. Hopefully you'll find the next 4 days are worth it. So actually, I skipped a page there. So I think with that many participants and that many people from around the world, and perhaps a number of graduate students and young people, a lot of people may be coming to this meeting just wanting to learn more about Gemini. So we are, as our name suggests, 2 twin 8-meter optical infrared telescopes, one on Mauna Kea in Hawaii and one on Sierra Pachon in Chile. And we are funded by the International Gemini Partnership, which consists of Argentina, Brazil, Canada, Korea, the United States through the National Science Foundation. And then our host locations, the University of Hawaii and Chile, are participants in the observatory. As you'll learn over the next couple days, there are many different ways to propose and to observe with Gemini. A lot of our observing is done in a Q observing mode, which enables us to be very efficient and very responsive to new targets of opportunity on the sky. And we also have a visiting instrument program, which allows us to bring to Gemini strategic and new capabilities that we wouldn't otherwise be able to provide to the Gemini community. Since 2019, Gemini has been a program of NSF's National Optical Infrared Astronomy Research Laboratory. So this is a new organization for the US federally funded ground-based optical and infrared astronomy facilities. And so Gemini is now partnering with the former NOAO facilities, which include Kitt Peak, Cerro Tololo, and the Community Science Data Center, and with the operations of the Rubin Observatory as it ramps up over the next several years. And you will hear more from our director, Pat McCarthy, about what this means for the Gemini community and what the future is for NOIRLab, as we affectionately call this organization. So it's undoubtedly been a really challenging year and a half for everyone. And I'm really grateful and proud to say that we've been able to keep the Gemini and NOIRLab staff safe while continuing to operate both the Gemini North and Gemini South telescopes. So right now we're in a situation where these telescopes are able to operate on a fairly regular basis on every night. In March 2020, we did have to shut down both telescopes for a period of time. Gemini North was able to come back on sky in May 2020. At Gemini South, due to COVID conditions that startup was later, we came back on sky in October of 2020. We're also very fortunate that our facilities and our staff are in locations where vaccines are widely available. And we're now able to have high rates of vaccination for our staff, making it much safer for them to continue their work. We've had a limited return to office in Hawaii and Arizona for a few months now. And with COVID conditions improving in Chile, we are planning a limited return to office there sometime in September. We are in a mode where we're only allowing critical travel. And there do continue to be fairly strict travel restrictions in and out of Chile. So because of all of that, as Janice mentioned, unfortunately, we've had to delay the in-person Gemini science meeting planned for Seoul, Korea, until August 2022, with final dates to be determined. But I think this meeting is showing to be a silver lining. We've gotten an incredible response. And I think the lessons that we learned this week will help us plan future virtual Gemini science meetings in years in which we do not plan to have an in-person Gemini science meeting. So despite all of the challenges of the past year, you, the Gemini community, have continued to produce amazing scientific results and beautiful pictures using data taken with the Gemini telescope. And this image is one of my favorite. So this is an image of the Carina Nebula taken with our multi-conjugate adaptive optics system in the south called GEMS with the GSAOI imager. This image was taken by Patrick Hartigan at Rice University. So over the last year, we've had a lot of fantastic science results come out, and I'm just going to show you a few highlights. This image was taken over a year ago, was released over a year ago. This is a fantastic high resolution mid-infrared image of Jupiter, which was taken at Gemini North using a technique known as lucky imaging, where the best seeing images out of a large number of images were collected together to create this incredibly high resolution picture of Jupiter. And when combined with optical images taken with the Hubble Space Telescope at a very similar resolution, these researchers were able to get a new look into the cloud structure of Gemini, particularly around the cloud structure of Jupiter, particularly around the Great Red Spot. In July of 2020, this result really highlighted Gemini's agile and flexible operations. They were able to quickly follow up a short gamma ray burst, looking for the optical afterglow within a few hours, and detect the host galaxy for this gamma ray burst to be at a very distant redshift, second most distant short gamma ray burst object known. You'll hear later today from Jacob Bean about one of our new visiting instruments, Maroon X. So over the past 2 years, Maroon X has been commissioning on Gemini North and has been attaining the first scientific results and is now available to the entire Gemini community. Maroon X is a high precision, high spectral resolution red optical spectrograph, really designed to obtain precision radial velocities for exoplanet systems. And this year it released some of the very first science results, achieving a radial velocity precision on the order of 1 meter per second, looking at one of a nearby transiting exoplanet system. And with this data was able to constrain the mass, the radius, and density and orbital parameters of this system. And then looking out to the very distant universe, also in January of this year, Gemini was able to detect one of the earliest supermassive black holes living in a quasar galaxy at redshift 7.642. So this was data, this redshift was determined with the Flamingos 2 and G-NIRS spectroscopy, placing this quasar only 780 million years after the Big Bang, during an epoch when the intergalactic medium was mostly neutral, providing a probe of early cosmic reionization and a first look at the formation of some of the first supermassive black holes and massive early galaxies. So looking ahead to the next decade, we are in the middle of a planning exercise to determine what Gemini should be doing in the 2020s. In 2019, the Observatory, in collaboration with our Science Advisory Committee and our board, released the Scientific Strategic Plan for the Observatory. And last year, NOIRLab released its scientific vision. And looking forward, what Gemini's priorities will be in the next few years are to maintain diverse and flexible operations and instrumentation capabilities for PI-led science, to become the go-to observatory for time domain astronomy in the era of Rubin operations and the LSST survey, to revitalize our adaptive optics program, particularly at Gemini North, and to enhance the support of you all, our users, and make it easier for you to turn your Gemini data into scientific results. So you'll hear a lot about our current and future instrument suite, and Ruben, I'm sure, is going to give a great update on this. I would say we have a wide variety of both imaging and spectroscopic capabilities spanning from the optical to the mid-infrared. And we also have a large number of instruments in development. These include GHOST, Scorpio, IGRINS 2, an upgrade to the Gemini Planet Imager, and a new multi-object spectrograph and imager called GEARMOS. So if COVID were not happening, I think at this meeting, we would all be talking about the first science results from GHOST. So GHOST is a high throughput fiber-fed optical high resolution spectrograph being built by a collaboration between AAO, ANU, and HAA. This is to obtain spectroscopy between 360 to 950 nanometers at 2 different spectral resolutions. And GHOST was on a slow boat from Victoria to Chile just as the pandemic hit. So now we are currently storing it at Cerro Pichon on the summit next to the Gemini South telescope. And commissioning for GHOST is just awaiting the lifting of travel restrictions into Chile. One of the other primary activities that we are aiming to do here with Gemini is to preserve non-time domain science while enhancing our ability to respond to targets of opportunity. This includes joining the AON Observatory Network, improving observer tools and interfaces, developing a dynamic scheduler, working on our data reduction pipelines, and building Scorpio, an 8-channel imager and spectrograph. Looking ahead, we're working on enhancing our adaptive optics and high spatial resolution capabilities. And you'll hear quite a lot about our new Gemini North Adaptive Optics facility that we're building with a new award from NSF to support the operations of GearMOS, this instrument that's being funded by the Canadian Innovation Fund. And then last but not least, if you're able to stick around for the last day, the last workshop, I strongly recommend that you attend Kathleen's session on Dragons, which is our new modular Python-based software for all facility instruments. So with my last slide here, I just say welcome. I've got virtual chats set up for Tuesday and Wednesday. If we've got any time left, I'm happy to answer questions now. But I'm really looking forward to this week, and thank you all for being here for this meeting.
Thanks, Janice. I'm sure everyone's clapping at home. I'm refreshing the Whova app to see the question. I think there's a, well, a little bit slow. There was a question asking about the current travel restriction in Chile, posted by Joel Rediger.
Yes. So right now, it's fairly difficult for non-Chilean residents to enter the country. There are quite a lot of restrictions about going in and out of the country related to concerns about bringing the Delta variant into Chile. And there's also very strict quarantines in place. So because of those reasons, we're limiting travel in and out of Chile to only critical travel. And then I think in terms of related to the GHOST commissioning, there are additional travel restrictions for members of the GHOST team. And we're just waiting to see if conditions improve and we're able to bring folks in.
Okay, thank you. Is there any other question, Janika, you're seeing? I think that's the only question I saw. All right. We have like 3 minutes, 3 more minutes for another question. So I'll ask questions. So like now we are entering to this ELT era. So can you briefly discuss the position of the Gemini in this our exciting the extremely large telescope era?
Sure. So there are a lot of interesting synergies between Gemini's capabilities and the aspirations of the extremely large telescopes. I think one obvious connection is this GearMOS instrument that's being built to be sitting behind our new Gemini North Adaptive Optics facility. This was originally conceived of as a TMT Pathfinder instrument. And so, you know, Gemini is going to help support the GearMOS instrument and also help TMT in that way. I think another interesting connection is with the US ELT project. You know, there's a proposal for some time from both the TMT project and the Giant Magellan project to be funded through NSF and have that time be managed by NOIRLab. And of course, Gemini operations, we have a lot of experience working with 2 large telescopes in 2 different hemispheres. So a lot of the software and policies and techniques that you'll be hearing about in terms of you know, making a Gemini system fit into AON and providing updated updated software for observing and proposing, a lot of those lessons learned are likely to be transferred over to the US ELT project.
Thanks for the comprehensive answer. So we are running out of time. So if you have any additional questions, I'm sorry, then you can use the Whova app Q&A tab in the Jennifer's session. And we're gonna move to the Ruben Diaz, the second talk on current instruments and upgrade overview.